are a million different versions of you? One could do homework, one could do chores, and one could play video games. What if there were infinite copies of you? This is the many worlds interpretation of quantum mechanics by Dr. Hugh Everett. A big mouthful, I know, so let's break it down.
What is it and how does it work? When quantum mechanics emerged in the 1900s, physicists divided the world into two parts: what is visible to the human eyes, macroscopic, and what isn't, microscopic. The macroscopic world is deterministic, meaning it is what we experience and is where cause and effect are connected. This is also called the classical world. The microscopic world is where objects are indeterministic, meaning we can never know the exact state or position of an object before we observe it. Knowing that the macroscopic world is made up of microscopic particles, Everett looked at a quantum mechanical equation by Dr. Erwin Schrödinger and thought, why can't we apply this to everything? Since the macroscopic world is made up of microscopic particles, Everett thought that everything macroscopic could also be quantum mechanical. Everett looked at the equation to calculate the probability that a particle such as an electron will be in a certain place at a certain time. This equation is called a wave function. Do you know the story of Schrödinger's cat in a box? Before you open the box, the cat could either be dead or alive. If you were to calculate the wave function for the situation, it would show you that the cat is both alive and dead at the same time. This idea of two realities being true at once is called superposition. It's as if the universe were film and it's been exposed to two images. But once we look in the box, we'll know immediately whether the cat is dead or alive, as if the images have separated, leaving one reality.
Everett's interpretation of Schrödinger's equation was that it could not only be used as a regular wave function to describe particles like electrons, but as a universal one to describe everything.
When the calculations are made, Schrödinger's equation tells us that multiple things are true at once, but when we observe the situation, only one thing appears true. Everett interpreted this as a split, or bifurcation of realities, each representing a different possibility. This would mean that there's a universe for every possibility, just like every particle, as allowed by fundamental physics.
It sounds crazy, and many physicists still think so, but it can actually make a lot of sense.
So what's the problem? If this theory were correct, it would raise important issues, a main one being, if everything has and will happen in one universe or another, then does probability still exist? This is known as the measurement problem that is yet to be solved.
It would be so hard, if it's even possible to solve, that it's one of the main reasons that physicists have not accepted the theory.
Most physicists, including Einstein and Schrödinger, subscribe to the best explanation they could come up with for the difference between calculations and the world as we understand it, saying that the principles of quantum mechanics apply when the object is not being observed, but if it is observed or measured, the wave function collapses, leaving only one possibility. This is the Copenhagen interpretation. Some see it as a scientific cop-out, since it raises even more questions than Everett's theory.
The many worlds interpretation, if ever proven true, could affect aspects of quantum mechanics, but even more so, the definitions of life, death, and the self. And besides, wouldn't you like to know if we were a little less alone? Hi, I'm Avalon. Thanks for watching, and I hope you learned something.